Hi everybody, this is Mrs. Pearson here. Myself and Ms. Van Dyke want to go over a way of showing functions that you are going to see in class as well as in activities that we work on. And that is called mapping. Okay, so when we were talking about functions, we were talking about a one-to-one correspondence. Remember, every input can have one and only one output. So this is a mathematical way of showing a function or something that is not a function. And we just want to make sure that you are aware of this way to show how a function is working. So it's called mapping, and functions are often represented in math by drawing mapping diagrams. The input values, which I hope you can see right here in this first section, are written in the oval on the left side, and the output values, here, let me change the color here, right here, are written in an oval on the right side. Arrows are then drawn to show which input and output values go together. So this is just a real easy way to show our inputs, our outputs, and the function that's taking place. Our inputs in this situation of a vending machine would be what we would put into the keypad. So we put in a D4 or a C2, and the arrow is drawn to the item that would be the output for that input that we put into the keypad. So this is how you would show it based on what is called a map. Now let's just give you some examples to talk about functions and non-functions with mapping. All right, so if we look here, we have to remember that maps are also going to show functions and non-functions, okay? So if we are going to look at this first picture of this vending machine, we have our input values, and our input values are going to be the codes that we put in to our vending machine, and those are written here. And I'm just going to put an I above this because this would be our inputs. Notice we have D0, D2, D4, D6. Now remember, our output value is always written on the right side of our ovals, and the arrow will connect each input to each output that we would receive. So if I punch in D0, I'm going to get tuna salad. If I punch in D2, I'm going to get Sour Patch. If I'm going to punch in D4, I get gummies. And if I punch in D6, I also get gummies. But that's okay because it's still a one-to-one correspondence. D6 will only give me gummies. Even though D4 also gives me gummies, that's okay because it's still a one-to-one correspondence. Maybe gummies are really popular, so they're going to put them in two different sections of my vending machine. There's nothing wrong with that. That is still what's known as a function. Let's check out some more examples. Okay, I wrote the word map here because this is an example of a map of something that is a non-function. Okay, let's talk about why. Our inputs are once again written on the left side of the oval, which is perfect. Our outputs is written on the right, which is awesome. And our codes are going to be our input, and our output is going to be what we're going to get out of the vending machine. So if I hit D4, I'm going to get pretzels. But look what's going on here with the C2. If I put C2 into my keypad on my vending machine, notice that I have two arrows coming off of the C2. Well, we all know functions have to be a one-to-one correspondence. Well, this doesn't look like a one-to-one correspondence anymore. Now I have a C2, which was my input, going to two different outputs. So my one-to-one correspondence is now a 1-to-2 correspondence. One input for two different outputs. How will I know what I'm going to get? I put in a C2. What if I get chips one time? But what if I'm really thirsty and I need a water bottle? So this will not work. So this is not a function. And that's how it is shown on a mapping diagram. Let's take a look at some more examples. Okay, so I went ahead and I wrote input and outputs above each one of these ovals so that you would see this. And I also highlighted some of my inputs here on my vending machine. So some of my inputs would be D2, D4, and D6. We all know that when I punch those in, I'm going to be getting some kind of an output out of this vending machine. Well, look what's going on here. I'm going to change my color. I have a D4 here, And it looks like my D4 in my mapping diagram goes to two different items. Does it go to the gummies like it shows here? Yeah, here's my one arrow going to the gummies. But look here, I also have a D4 under Sour Patch Kids. So now an arrow that's connected to the same input of D4 is also leading me to Sour Patch Kids. So this, which used to be a 1-to-1 correspondence, now is a 1-to-2 correspondence, because when I punch in D4, I have absolutely no idea if I'm going to get Sour Patch or gummies. So this is not, oh, that's terrible, not a function. Not a function. All right, let's keep moving on. Oh, here comes some new terminology for you. It says domain and range of functions. This is some new terminology that also represent the words inputs and outputs. It says the set of all input values is called the domain. I'm going to underline that, of the function. So inputs are also known as the domain of the function. The set of all output values is also known as the range of the function. Luckily, there's a very simple way of remembering this. Notice the word domain here. If you can see, the last two letters of this word is in. Notice what it matches, but the in input. So the in domain also represents the input values. The IN tells you input. So the domain is always the input. The range is always the output. So let's just think about our vending machine right now. And I'm going to go ahead and type this. It says, what would be the domain and range for the vending machine? Well, the domain is what you type into the keypad, or the input. The range is what you receive from the vending machine, or the output. So the input or the domain would be the code that I would punch in, and the output or the range would be whatever I get as my snack. And remember, the domain is still always written first, and then the range comes second with arrows going from one to the next. Now I want you to try. Here we go. I would like to know, first of all, ooh, sorry about this. Oh gee, I think I just gave you the answer, which is terrible because that's not fun. All I want to know is this. Is this a function? Yes or no? Go ahead and answer the question. Is this a function? Okay, let's try the next one. The next one, oh boy, looks like this. Is this a function? Yes or no? Last but not least, we want you to try one more for us. Just one more. Is this a function? Oh, sorry about these arrows. Let me get rid of those. You don't need those to tell whether it's a function or not. Is this a function? And then you know what I want to know too? I want to know which one is the domain. Is it the names or is it the food items? Which one is the domain? All right, good luck. Bye, everybody.